Okay, so with the worksheet, here's what we got to make sure everybody's okay with first. That if it's going to ask you to, and this is where we're going to use our unit circle, if it asks you to find the cosine of pi over 3, remember that's in this case, you're going to find pi over 3 on your unit circle. Cosine is the first value, so that's 1/2. So if they ask you to evaluate cosine of pi over 3, then the answer is going to be 1/2. And yes, I do need y'all to fill this in as we go along. This is your notes for the day. Okay. If they ask you to find, I think the pink's going to show it better. If they ask you to find the sine of pi over 3, again, you go to pi over 3, sine is your second number, so that should be square root of 3 over 2. And if you've taken any look at your homework, you should know by now that those numbers are kind of popping up there. We'll get tangent here in just a minute. So we do pi over 2. Again, that'll put you here. Cosine is the first number, sine is the second number. So we can put 0 and then a 1. And hopefully what you're kind of noticing is that whenever you're doing these, the ordered pairs are your cosine and your sine values. Pi over 6, square root of 3 over 2 for cosine, sine's going to be 1/2. If we go to pi over 4, that one should be the exact same answers for both of them. Okay. If you go to pi, cosine's -1, sine is 0. Go to 330, should be square root of 3 over 2 and then -1/2. All right, -45. Now here's where we tie in with what we were doing yesterday. If it's -45, that basically, if it's a negative number, you just take that number and you put it with 360. So if it's a -45, it's 360 minus 45. That's the same thing as 315. So that means we're going to use square root of 2 over 2, negative square root of 2 over 2 for our cosine and our sine values. So if they give you a negative number, just add that number to 360, or in this case, you would subtract it from 360. And that tells you the same thing because now you're coming down 45 degrees, which means that it's going to put you at the 315 mark. So that's going to be our cosine and our sine values there. All right, -7 pi over 6. And again, you're probably not really thinking about this in terms of radians, but if you had 7 pi over 6, that's 210. If it's -210, you do 360 minus 210, that means you're going to be at 150. So if it was a -210 degrees, that means you're going to wind up back here at 150. So now that's going to be our, that's going to be our cosine and that's going to be our sine values. So negative square root of 3 over 2 and then 1/2. All right, 720, not on the board, right? But what we said yesterday was if it's 720, we can just take that number and subtract it from 360, or take 360 and subtract it from it. So 720 would basically be the same thing as being at 360, which is also the same as being at 0. So that one's just going to be 1, 0 for our sine and our cosine. All right, and then our last one, 13 pi over 2. And you're like, okay, there is no 13 pi over 2 anywhere on the sheet, right? So this is where you got a couple options you can do. Okay, this would be 1 pi over 2. If you get to pi, okay, that would be 2 pi over 2. And then the 2's would cancel, just give you pi. This is 3 pi over 2. So every 90 degrees, you get another pi over 2. You got 4 pi over 2. That's going to cancel, make it 2 pi. So this would be 4 pi over 2. This would be 5, 6, 7, 8, 9. What number are we going to? 13. 9, 10, 11, 12, 13 pi over 2 would wind up back over here at this point. So that's going to basically be the same thing we've got here at 0, 1. So if they give you a number that's basically bigger than what you can do, you can just kind of look at your denominator and figure out, if this was 1 pi over 2, we know we'd be here. If it was 2 pi over 2, we'd be here. So basically every time they give you another pi over 2, you're just going another 90 degrees to get there. Okay. Now, one other thing you could do is that you can also kind of put it back in your memory on this one if you're doing these, is that every odd pi, this is 1 pi, this would be 3 pi, this would be 5 pi, this would be 7 pi. Since this is 2 pi, if we went around again, it would be another 2 pi, that makes it 4 pi. If you go around again, it makes it 6 pi. So if you're doing whole numbers, every even pi is over here, and every odd pi would be over here. And if you took 13 pi over 2 and converted that into a mixed number, that'd be 6.5 pi. So if 6 pi puts you here, you got to go one more pi over 2 or half a pi, which would wind up putting you back here. So you can look at it a bunch of different ways as you go through those, and just find some way that kind of makes it click in your head, and then you go from there. All right. For tangent, here's where we got to do a little bit of work. And some of this we're going to do on the back, because some parts of this we're not going to be able to get everything here. That when we do tangent, hopefully everybody remembers when we do tangent, it is sine over cosine. And you can't see that, so I'll scoot back down. There we go. All right, so if we put square root of 3 over 2 over 1/2, here's where you got to go back to your middle school days again. We're going to keep it, we're going to change it, and we're going to flip it. That's going to make it square root of 3 over 2 times 2 over 1. And the good news on that one is your 2's cancel, leaves you with square root of 3 over 1, which is just square root of 3. Okay, so they ask you to find the tangent of pi over 3. You're going to put the sine value over the cosine value, and then you simplify that fraction. Okay, and we'll do the same thing for this one. So if they ask you to find tangent of pi over 2, which is what they're asking you to find here, that's going to be the sine over the cosine. So that's 1 over 0. Oh, here's a great question. What is 1 divided by 0?
1 or 0?
Oh, there we go. Undefined. Remember, if 0 is on the bottom, it's undefined. If 0 is on the top, then it's 0. Which one? Okay, so 0 on the bottom, undefined, 0 on the top, it should just be 0. Okay, now for the next one we get, we're going to do this one on the back because there's really not enough room to do this one right here. So flip it over on the back. Try that again. Flip over on the back here. We're going to show you that one because if we do tangent of pi over 6, that's going to be 1/2 over square root of 3 over 2. So if we're going to do tangent, it's sine over cosine. And that winds up being 1/2 over square root of 3 over 2. All right, we're going to keep it. We're going to change it. We're going to flip it. So it's going to make it 1/2 times 2 over the square root of 3. Okay, and at first look, you go, well, hey, this was a good 2 because when we do this one, it's the 2's cancel out, which you're correct. And that's going to leave you with 1 over the square root of 3. All right, now here's the thing. Eventually one day you will not have to worry about this, but unfortunately in the meantime you have to worry about this. They tell you cannot have a square root in the denominator. That for now, and again, this is going back to the old days when they used to do everything by hand. We've got enough computers now that I think we're probably safe on this one, but I don't know why they've gotten rid of this and they still insist on doing these. But in the meantime, they still make us talk about doing that one. So what we're going to do, so what you're going to do is you're going to rationalize the denominator, which basically means that we're going to eliminate the denominator in variable. Or say we'll eliminate radical variable. Or let's try it again. We're going to eliminate the radical in the denominator. Because any of the answers that you're going to do, if you leave this answer as 1 over square root of 3, they're going to count it wrong. Okay, now technically, here's what we do for this one. So if you've got 1 over square root of 3, if they ask you to rationalize the denominator, basically here's what you're going to do. You're going to take whatever radical you have in your denominator, and you're going to multiply by whatever that radical is in the denominator. So we had 1 over square root of 3, so we're going to take the original problem we've got, we're going to multiply by whatever we have in the denominator.
Over each other?
Yep. Because it's basically like multiplying, if it was like getting common denominators, how you have to multiply like the bottom number by 2 and the top number by 2. Basically, same thing in this one. If we're going to multiply the bottom by 3, we also got to multiply the top by 3 to make it even out. Okay. The good news is on the bottom, if you do that on the bottom, it gives you square root of 9. But what's the square root of 9? Just 3, right? There you go. So that's your answer where it's rationalized because you don't have a radical in the denominator. Okay, so final answer for this one is we're going to do square root of 3 over 3 for this answer. Okay. So over here, where we're doing that one, we're going to go back and we're going to put square root of 3 over 3, and we're going to put C back for work. Oh, sorry, there we go. Try it again. There we go. So there's our answer. And again, we're just going to put, instead of showing the work over here, we're just going to put it on the back of it. Because again, there's not really a good way to get that thing over here just to make it all work out. Because it's just not enough room to get everything on here. Okay, now, y'all ready for the shortcut? So for the shortcut on this one, you're going to move the radical to the top. So this square root of 3 that we had that was here, we move the radical to the top. And then you just leave the number on the bottom. So we took the square root of 3, moved the square root of 3 to the top. On the bottom, we're going to leave the square root off and just put the 3 on the bottom. That way, and it's still doing the same thing. It's just a little bit of a shortcut to do that. So if they gave you a number, so if they gave you like 2 over the square root of 7, and they ask you to rationalize it, you're going to move this radical to the top, and then on the bottom, you leave me just the number. So it's going to be 2 square root of 7 over 7. Right, now, if you happen to have something you could simplify, let's say this had been 2 over, let's say we were doing, well, I guess we could do that here. Let's say instead of being 7, this thing had been 10. You can leave it that way if you want to. But let's just do a what if this part was 10. If you wind up getting something you can simplify, like this one, if you've got 2 over 10, then you can go ahead and cancel that part and make it square root of 10 over 5. Okay, so shortcut again is take your square root, move it to the top. On the bottom, you take the square root away and just give me the number. And then it's 50-50. Half the time you'll be able to simplify, and then half the time you won't be able to simplify. Okay, now, and again, that's probably one of those things that eventually that will, because go away because we've got enough stuff. We know calculators now. We've got enough technology. We can do this. It's just back in the day when they were doing everything by hand, if you had square roots in the denominator, it just made the work a lot more tedious. And so they said, all right, let's just get rid of this one because if we're going to start adding, subtracting fractions, it's easier to add or subtract with 3 for a denominator than it is with square root of 3. We've got enough calculators now to do stuff that, to me, that should probably go away. I just don't know if it'll go away in your lifetime. Probably your kids will. You'll be like, well, back in my day, we had to rationalize the denominator. We didn't get to take shortcuts, dude. So, I don't know. Maybe one day we'll get there. All right, so for number 4, here's good news on this one. What happens if you take square root of 2 over 2 and put it over square root of 2 over 2? What happens when you put the same thing over itself? Yeah, just get a 1. Okay, so for this one, again, we're doing tangent of pi. Again, that is sine over cosine, which is 0 over negative 1. So this one was undefined, so this one should just be 0. 0 on top, the answer is 0. 0 on the bottom, it's going to be undefined. All right, now here's where we want you to kind of leave this paper out. This is where I want you to start noticing patterns. If we do tangent of 330, it's sine over cosine. It's negative 1/2 over square root of 3 over 2. Oh, but wait a minute. Didn't we do the exact same thing right here? If we go back, and I wish I'd written that down in there in a block, and I didn't. It was 1/2 over square root of 3 over 2 for this answer, right? So don't worry about recreating the wheel because you've already got this answer right here. You know this one's going to be square root of 3 over 3. So for this answer, just know that it's square root of 3 over 3. But what happens? Oh, sorry, good when you see it here. What happens when you divide a negative and a positive? Yeah, the answer is just going to be negative. So if you have this chart and once you set it up and you see what your sine and your cosine values are, you don't have to worry about calculating any values. You just look through the list here and go, oh, there it is. It's this over this. I know the answer is this. If it's negative 1/2 over square root of 3 over 2, the answer is always going to be square root of 3 over 3. Could be negative, could be positive. Just kind of depends on what we're doing there. So if you're doing the negative 45, we know it's going to be this over this. It's the same thing over itself, but what happens when you put the same thing over itself? It's 1, but what happens when you have one negative and one positive? Should just be a negative, right? Same thing as this answer. It's just now we've got a negative divided by a positive, so that means that answer is going to be a negative. Okay, and if you notice your values here, same numbers here. We're going to do a positive divided by a negative, so we know this answer is going to be a negative square root of 3 over 3. And again, there's only so many values. If you notice on the unit circle, there's only so many times. There's really only 1, 2, 3 different numbers. So there's really only like 3 different. Well, I mean, if you do 0 over 1, you can get a different answer there. So you're only going to have so many answers before everything's going to repeat. If you do 0 over 1 on this one, 0 is on top. The answer is 0. If you do this one, it's 1 over 0. 0 is on the bottom. It is undefined. Okay, so you're not going to have like 1,000. It seems like you may have like 1,000 different answers, but you're not because there's only so many combinations you can do with these numbers that's here. So all the answers, if you're doing tangent, basically there's every possible answer you could have. It's either square root of 3, it's undefined, it's square root of 3 over 3, or it's 1, or 0. And that's it. Everything else is just going to be some same answer. It's going to be either a negative or a positive, just depending on how you do your signs for those. Okay, so for secant, we haven't talked about secant yet. So maybe flip over on the back here. All right, secant. The shortcut for that one is SEC. Did anybody talk about that in geometry? Okay. If you did, you got a little bonus, something extra. If you didn't, you didn't. So we're gonna make sure everybody got everything you should have gotten when you went through this thing. You need to get your money's worth out of your free education. All right. So the shortcut for secant is SEC, and for secant, it's going to be 1 over the cosine value. All right, they got another one that they're going to call cosecant. Now, and they couldn't do COS because we already did that for cosine. So for cosecant, the shortcut for that one, they're going to do CSC. And that's going to be 1 over sine. And then the last one we have to look at is cotangent. The short for that one, we can do just COT. You can do that one as 1 over tangent, or it's going to be cosine over sine. Because if it's 1 over, that's basically the inverse. So if you take tangent, which was sine over cosine, and you flip it, you're going to get cosine over sine. Okay, and we're getting really close to the end on this one. All right, everybody got all those written down there? Okay, so back over here, I'm going to fold this so we can go back and see what's going on with it. So if we're doing secant, we said it's 1 over cosine. So when we do secant, you can basically cover up anything else that's not cosine. Okay, because again, secant is 1 over cosine. So for this one, it's going to be 1 over 1/2. And again, it's 1 over something, so we're going to keep it, we're going to change it, and we're going to flip it. So it's going to be 1 times 2 over 1, which is just 1 times 2. So the answer would just be 2. Okay. So they ask you to find the secant of pi over 2. You've got to know that that's 1 over cosine. So that's 1 over 0. Oh, and we've run into that before, right? What is 1 over 0? Undefined. If you didn't know that by now, probably by the time you get through the homework, you're probably going to be pretty good at knowing that 1 over 0 is undefined. You're probably going to do it enough times, it's going to kind of get hammered into your head. And remember, Casio calculators, you cannot use them on this test. You can use the Texas Instruments that's up there. There's a couple of Texas Instrument calculators that you cannot use, but I have to kind of look at those on an individual basis and see what we got. All right, now here's where the fun kicks in. Because if we do 1 over square root of 3 over 2, we're going to keep the 1, we're going to change the division sign, and we're going to flip the square root of 3 over 2. Okay, and we're going to run out of room. Actually, we'll put it out beside over here. We'll be okay. If we run into the cosecant part of this one, it'll be fine. So that's going to be 1 times 2 over square root of 3. Okay, now the good news on this one is if it's 1 over or 1 times, we're not really going to have to worry about the 1. It's 2 over square root of 3. But again, they say, all right, if you do this one, you cannot leave that square root of 3 in the denominator, so we're going to rationalize it. So we're going to move that square root of 3 from the bottom to the top. And on the bottom, we're going to leave just the number, so we're going to leave just a 3 there. So for this one, we'll kind of do that. For our cosecant, for our secant answer. All right, everybody okay with what we did there? Because again, secant, it's 1 over the cosine value. So that's 1 over square root of 3 over 2. So it's all, and again, kind of good thing is on this is all you're going to do is you're going to take this secant value you got for your cosine value and just going to flip it upside down. If you need to rationalize it, you rationalize it. If you don't, then it's not a big deal. Okay, so this one, it's 1 over square root of 2 over 2. Again, keep it, change it, and flip it. which means, again, the 1 doesn't really do anything. So it's 1 times 2 over the square root of 2. But again, the 1 doesn't really have an impact there. So this would be one where, again, we're going to rationalize it. The 2 is already there. We're going to move the square root of 2 to the top. On the bottom, the 2 is going to stay by itself. And for that one, works out kind of nice. The 2's cancel each other, which leaves us with just the square root of 2. All right, everybody okay there with that one? Because again, it's 1 over square root of 2 over 2. Keep it, change it, and then flip it. Again, if you multiply by 1, it doesn't really do anything. So basically our answer is 2 over square root of 2. And then you got to rationalize it. So we move the square root of 2 to the top. We'll leave just the 2 on the bottom. That 2 that was already there, those will cancel, and then we're left with just square root of 2. Okay, then you get some easy ones like this one. So it's 1 over negative 1. Well, that's easy enough. That's just negative 1. This one is 1 over square root of 3 over 2. But again, you do not have to recreate the wheel because you've already got a 1 over square root of 3 over 2 answer right here. So for this one, once you know it's 1 over square root of 3 over 2, you know the answer is going to be 2 square root of 3 over 3. And somebody's probably thinking, are we going to have to show our work when we do these? No, you're not. You're just going to have to be able to find that answer and know how to get there. Probably a lot of these questions, it's probably going to be a mix. Some of them will be fill in the blank. Some of them are going to be some multiple choice because it's just a matter of being able to work through it on this one. If you do the 45, again, it's 1 over square root of 2 over 2. But again, we just did that one right here. So this answer is just square root of 2. If you get ready to do number 8, it's the exact same number that's here. The only difference is this one's negative. So this one's going to be the exact same answer. It's just going to be negative. Okay, this one's 1 over 1. Just 1. This one's 1 over 0. Again, hopefully by now, if it's 1 over 0, you know it's going to be undefined. Okay, you want to know the good news for cosecant?
Sure.
It's 1 over sine. You've already got all your answers right here because if you go to cosecant, if we do cosecant on this one, we're doing the cosecant of pi over 3. And again, cosecant is 1 over sine, so this would be 1 over square root of 3 over 2. But again, you've already done that part right here. We know this answer is going to be 2 square root of 3 over 3. So whether you're doing secant or cosecant, you're going to basically use the same answers. It's just, depending on which number they give to you, because we've already listed every possible answer you can get for secant or cosecant right here when we go through this list of numbers that's here. So you don't have to worry about recreating the wheel. So if we're doing the cosecant of pi over 2, which was this number back here, we're doing 1 over 1. Well, that's easy enough. That's just 1. So there's not any, if you can do the answers for secant, you've also got the same answers for cosecant because it's just a matter of doing the exact same thing through there. Okay, and if you do cotangent, again, it's cosine over sine. And then pretty much, again, it's the same thing as it's going to be the same answers you're going to have for cotangent as you're going to have for tangent. Because it's the exact same numbers, you're just going to reverse the order a little bit. So if we go to tangent, I don't have to do this. I'm just going to do this so I can get it so y'all can see it easy. I'll fold this back. Okay, so if we do cotangents, cosine over sine. So for this one, that's 1/2 over square root of 3 over 2. But again, if you would go down here and look at this problem right here for number 6, that's the exact same thing we had for number 6 because it was 1/2 over square root of 3 over 2. So we've already done that answer here when we were doing cosine. So for this one, we know the answer is just going to be square root of 3 over 3. So every answer you've got for cosine, it's also going to be the same list of answers that you've got, or sorry, for tangent. It's going to be the same list of answers you've got for cotangent. You just got to go back in and find out, where that number is on that list as we're going through it. All right, this one should be easy because if we do this one, it's just cosine over sine is 0 over 1. Hopefully everybody knows that's 0. If we do this one, it's square root of 3 over 2 over 1/2. And if we look back at our our tangent values, we find square root of 3 over 2 over 1/2. Well, that was right here. There's square root of 3 over 2 over 1/2. That answer was just square root of 3. Okay, and you can keep going down the list and you can have the exact same answers. But again, you don't have to keep going down the list because every answer is here. You've already found that answer here when you found the tangent answer. Because again, it's just reversing the order. And if you reverse the order, you get back to the options that you've got there.